50% of the habitable land, what we humans could use if we wanted to, is used for agriculture.
Thank you very much.
Thank you.
My name is Max.
My name is Tim.
From the Plant-Based Treaty Initiative. And we're here to tell you today why killing animals is actually killing us. As we all know, in our society, there's a massive blind spot for animals and the things we humans do to them. So it's no surprise that the environmental implications of this human activity also get overlooked a lot. And not only in the broader public, but also in the climate movement, for example, which is a big problem. So we are here to make a case for that animal agriculture and fishing is actually the most dangerous and destructive human activity on this planet today, and we believe there's overwhelming evidence for that.
Of course, we are well aware that using environmental facts in a normal outreach situation may only inspire people to adopt a plant-based diet, but not to adopt an ethically motivated anti-speciesist lifestyle for the animals, because veganism is so much more, isn't it? But it's okay when people go plant-based first and do the step to veganism later. Because a plant-based diet may be the most important measure for mankind to reduce the pressure on our planetary boundaries. And a plant-based for the planet lifestyle is arguably the best first step in becoming a vegan.
In standard outreach situations, we animal rights activists mainly focus on the ethical reasons for adopting a vegan lifestyle, whilst viewing additional reasons like environmental arguments as mere support arguments to achieve at least part of this goal in the form of a plant-based diet.
Unfortunately, those environmental support arguments we use are often limited to the greenhouse gas emissions of animal agriculture. But climate change or greenhouse gas emissions is not our best supporting argument, because in the end fossil fuels apparently cause more greenhouse gas emissions than animal agriculture, and there are contradicting figures on how much share the emissions from eating animals may be. You'll spend too much energy discussing which figure is right and which industry is worse.
So researching the scientific data on the impacts of animal farming and fishing for our PBT campaign, we came across much stronger environmental arguments than the greenhouse gases and their global warming potential. In our following presentation, we'd like to share our knowledge to help you improve your outreach concerning the environmental impacts.
So, did you know global warming or greenhouse gas emissions is not the only environmental argument? In fact, it's not even the best argument.
Yes, so we want to present to you the concept of planetary boundaries. It's a concept developed by very renowned scientists, among others from the Stockholm Resilience Center. You might know Professor Dr. Johan Rockström. He also appears in a Netflix documentary called Breaking Boundaries. So they represent 9 highly interconnected processes that regulate the stability of Earth systems. And as you can see, it's not looking very good. There's a lot of red. We have exceeded the so-called safe operating space, which you see in the middle, that's the green circle, already in 6 of those planetary boundaries. One hasn't been quantified yet. And yeah, 2 of them are actually called by those scientists core boundaries. So it's climate change, but also biodiversity, or how they call it, biosphere integrity. And so these core boundaries mean that even if just one of them is exceeded for too long, it can make the planet single-handedly uninhabitable. And we believe it's very important to look beyond just CO2 emissions to understand the true impact of exploiting animals, using animals as food mostly. And it's also, I think, very important to understand how the future on this planet is going to look like and how we need to collectively find answers how this is going to affect our activism, because obviously we have a very rapidly closing window in time where we can still make change.
Wait. So we're going to show that animal agriculture is the main driver of most of the plant-based, the planetary boundaries, and to argue only with greenhouse gas emissions is to ignore all the other reasons.
Exactly, and now we're going to show you the very core reason why using animals is so inefficient and destructive, and it's called the 10% law. This is very old science. It was already discovered in the 1940s, so it's not something that's very easily debunked by animal agriculture lobbyists, for example, and it's about energy conversion between trophic levels. So trophic levels indicate the place of an organism in the food web. So on the bottom left, you see producers, being plants. They store chemical energy from the sun, and they transfer it to primary consumers, which are sadly on this planet mostly farmed animals, but ideally us humans. And then if humans decide to eat animals, we accept energy losses in the range of 90%. As you can see, 90% of the 100 calories that we initially had are being lost to the environment through motion energy, respiration, and other metabolic processes. And this means that only 10 calories at the end go to the secondary consumer in the form of humans. And if we want to have a lot of those 10 calories or 10%, then obviously we will get a lot more of the 90% that's being lost to the environment in the form of greenhouse gases, manure, and other very damaging substances. But also we need to replenish it, because if you have a cycle with an element that's extremely inefficient, where you have continuously 90% energy lost, you need to replenish it all the time with land, with fertilizer, additional feed, water, and also on another level with subsidies, because such an inefficient system can only go on through external support. And a very helpful analogy I find is to view animals, farmed animals, as extremely inefficient bioreactors. And we're using 80 billion of them every year. And obviously, this is going to cause an extreme amount of damage.
So now we're going to go through all the planetary boundaries counterclockwise. And the first one is biosphere integrity. And this is also known as biodiversity loss or species extinction. And as this sounds very theoretical, we have to see that there are lives lost. I mean, when species go extinct, it's suffering of non-human animals in the wild. So we should never forget this when we look at those numbers. Biosphere integrity is divided into genetic and functional diversity. The functional diversity has not yet been quantified. And biodiversity is important for the ecosystem resilience. The more biodiversity have, the less impact extreme weather or other events can have on ecosystems. And animal agriculture is the main driver of this planetary boundary, because of pesticides and other toxins we spray on the agricultural land, antibiotics, genetically modified organisms, habitat destruction, eutrophying and acidifying emissions. We come to that later, what that means, eutrophying. And fishing is the main cause in the oceans. So, yeah, animal agriculture is the main cause for the exceedance of this boundary. Here you can see the normal background rate. You can find this background rate in historical data when geologists search for biodiversity in the past. And the normal background rate of extinctions per 1 million species per year is 0.1 to 1. And the planetary boundary they defined is an extinction rate of 1 to 10. So it's already 10 times more than the normal background rate. And now I'll show you the actual background rate. It's 100 to 2,000. So the actual background, the actual extinction rate is 100 times greater than, this planetary boundary, and 1,000 times greater than the normal background rate. And when we go back to this, the green part, the safe operating space, is this 1 to 10. And so the exceedance should be 100 times bigger, but you couldn't fit it in this graphic. So there was an interview in a German scientific magazine, and Matthias Glaubrecht is a professor for biodiversity, and in this interview he said, ignoring species extinction could be mankind's biggest mistake.
We might be able to reverse climate change, but we cannot reverse the extinction of species.
And here's how he explained why. I think this is a very nice picture. I'm going to read it to you. Biodiversity is a genetic database. Imagine the biodiversity of our planet as a hard drive in a computer, and we keep deleting more and more data from it. Maybe in the beginning just some memories get lost, but we also delete data which we have never had a look at, and even whole program parts whose function and meaning we have no idea of, until the loss of data leads to a system crash and we don't have a backup. There's no planet B.
Yes, so very clearly this is even more dangerous to humanity and all life on this planet than climate change, but it's not being talked about. And here we want to show you an example, so how the causes for the decline of insects, for example. And you see it's split up into different economic branches, but if we look at it from a different perspective, so which parts are being affected by animal agriculture or agriculture in general, then we have to actually combine all these sectors to get a better understanding how damaging this really is.
And as you can see, agriculture is responsible for more than 50% of the insect decline.
Yeah, sorry. That's the takeaway from this. And interestingly, in Germany, there was a study, for example, the Krefeld-Studie, that found over a period of 25 years, there was a loss of, I think, 75 or 80% of insect biomass already. So that was already back in 2015.
And that was in protected ecosystems.
Yeah, so absolutely shocking. Another very shocking graphic. This really shows how much animal agriculture has changed the face of this planet. So probably many of you are already familiar with these figures, but it's just insane if you think about it. It's hard to understand. So 62% of the global mammal biomass is our farmed animals, then 34% are we humans, and then only a tiny fraction of 4% are wild mammals left. And because this number is so small, they decided to include the marine mammals. So we're comparing land and marine wild mammals to humans and farmed animals on land.
So the next planetary boundary is land system change, also known as land use change, habitat loss, or ecosystem destruction. And this is calculated primarily over past and current land clearing, so it's not the actual per year clearing of land, so it's a total. And the main metric for this planetary boundary is forest cover, but there are also other metrics to calculate this planetary boundary. And it's highly interconnected with all the other planetary boundaries, because when we destroy ecosystems or habitats of wild animals, of course, biosphere integrity or biodiversity gets impacted. Or climate change, because we destroy carbon sinks. Or freshwater change, because on that land there's no more vegetation that powers the water cycle. And again, animal agriculture is the main cause for land use change. About 76% of the deforestation is wreaked by animal agriculture. Here you see a graphic on how the land surface is divided in different parts. On the top column you see Earth's surface. Of course, in the oceans we can't do agriculture or anything other. We can't build cities in the oceans. So 29% of Earth's surface is land. And only 71% of this land is habitable, because the rest is deserts, glaciers, barren land you can't use. And 50% of the habitable land, what we humans could use if we wanted to, is used for agriculture. And 37% are still forests, but mostly forests where we take timber from. 11% is shrub, so this is like savannas and things. And as you can see here, only 1% of this area is built up, so this is concrete roads and industrial sites and cities. So when people say, yeah, but the cities and we are too many people and the cities are growing, no, animal or agriculture is 50 times more taking space on this planet. And of this agricultural land, 83% are used for producing livestock and animal products, and only 17% are used for plant-based food. But these plant-based foods provide us with 82% of the global calorie intake, whilst animal products only provide us with 18% of calories.
Yeah, I think that's a very profound example again of this 10% law, where we see how inefficient it is, for us to use so much land for animal to produce stuff that we really don't need in most parts of the world.
Yeah. So George Monbiot stated, land use, I believe, is the most important of all environmental metrics. The land we use for extractive industries, of which farming uses by far the most, is land that can't be used for ecologically and carbon-rich ecosystems, wild forest, wetlands, savannas, etc.
Yeah, then very interesting and also very dangerous planetary boundaries are novel entities. You could describe it simply as chemical pollution, so stuff that we humans have created or dug out somewhere, like heavy metals or radioactive materials, spilled it out into the environment, and we really don't know what it's actually doing there. And interestingly, within that planetary boundary, it's hard to quantify, but animal agriculture is definitely, because we use so much land, again, the main cause for the use of pesticides, for animal feed, for antibiotics, of course, we all know that, and also GMOs. And it's in fact the only industry that openly distributes it in nature. Other industries like the chemical industry tries to keep it in. Here and there's an accident, but yeah. And there you see a global production of these substances is really on the rise. Obviously, this is also used for other industries, but yeah, we believe it's incredibly important to address this boundary as well, because, for example, antibiotics and overuse of antibiotics and ensuing antibiotic resistance, which we are already seeing, could really catapult us back into a dark age of medicine again, where you get a small scratch and you might die from it, or even a visit to the dentist could be fatal.
So the next planetary boundary is biogeochemical flows, aka eutrophication. I used that word before. And this means excessive richness of nutrients in water bodies, setting off a chain reaction in ecosystems. And the P and N are phosphorus and nitrogen. And yeah, this leads to ocean dead zones, as you all may know. And again, animal agriculture is the main driver of this planetary boundary because of over-fertilization through manure from over 80 billion land animals we slaughter per year, and artificial fertilizer for feed production. And of course, aquaculture is also a main driver because the nutrients by the feed and by the feces of the fish is very concentrated in these areas. And yeah, fun fact, artificial fertilizer, we have now double, so it's the double amount of nitrogen in the world, because we sucked so much nitrogen out of the air by the Haber-Bosch process to create artificial fertilizer, that it's the same amount we had as nitrogen before. So when you take a look at your body, 50% of the nitrogen atoms in your body come from the industry, from a factory. Yeah, here you can see a satellite picture. The red area, this is Europe, and the red area in the North Sea, this is algae bloom. So this is the stage before the dead zone occurs, and this corresponds to the region where we have the highest density of farmed animals
in Europe.
In Europe. Yeah, this is a world map, and as you can see, the black dots are dead zones in the oceans, and the more the color gets to red, the more fertilizer is used. So you can see there's a distinct connection between fertilizer use and dead zones. And so this is, yeah, again, animal agriculture or agriculture is the main cause for eutrophication and over-fertilization of our soil.
Yeah, and I think it's important always to visualize that within agriculture, because our global agricultural system is so geared towards animal production, this is taken the lion's share of the impacts of agriculture in general. So coming to the next planetary boundary, it's freshwater change. It's also a vital planetary boundary for everyone on this planet, and it's divided in blue water. So this is water that's stored in lakes, rivers, but also below ground, and then it's green water, which is available to plants. So it's stored in plants, but also circulates and rains back down. So if you imagine the Amazon rainforest, for example, which is creating its own weather system, this is all green water. And agriculture accounts for 70% of freshwater withdrawals. And as I said before, animal agriculture is takes up most of it. It's quite hard to find detailed figures on this, but it's very very robust to say that it's like this. And yeah, I always want to when it comes to green water, I want to refer to a tweet by Dr. Peter Kalmus, the famous NASA scientist, and he said that behind closed doors, rainforest scientists are already talking about that the Amazon has passed its tipping point, so it's not able to create its own weather anymore because we have changed the forest itself and also the surrounding savannas so much that there's not enough vapor, water vapor anymore that can keep this cycle of rains and evaporation going, which is incredibly scary to me.
As you may know, 1 kilogram of beef needs 15,410 liters of water, and 93% of that is green water. And as we heard, green water is stored in plants, so you can imagine if the cow hadn't eaten all the plants, and beforehand we had destroyed or deforested the rainforest at that point, and would have incorporated that water in its flesh, then there would be a forest and not a pasture.
All right, and last but not least, we have climate change. It basically means the heating up of our atmosphere because we're changing the composition of the atmosphere with our greenhouse gas emissions. And there are a lot of conflicting numbers out there. We have compiled some of the most famous, and we believe that the number in the middle, so the 28% by the Oxford University from 2018 from Poor and Nemetsek, is the most reasonable number out there at the moment. And it's important to note that they include like direct emissions from the animals, of course, from burning down forests and the supply chain of the animal industry, but also, maybe even more important, the carbon opportunity costs or land opportunity costs. So that means ecosystems that can't provide the services we need because we are farming animals on this land instead of regenerating carbon sinks, for example, or habitats where biodiversity can get boosted again.
Simply put, if there wouldn't be a pasture or a field with animal feed, there would be a forest, and that could sink out carbon of the air.
Yeah, at least here in Europe, all the pasture land that we have now used to be forests. Okay, and yeah, here again we see this Pareto ratio, so 80-20 basically. 83% of the European average diet comes from animal products, and another manifestation of this 10% law. We're going to go through the rest of the slides a bit faster.
Yeah, there was a study in 2020 by Clark et al. And they said global food system emissions could preclude achieving the 1.5 or even the 2 degree Paris Agreement limits. And they stated, even if fossil fuel emissions were eliminated immediately, emissions from the global food system alone would make it impossible to limit warming to 1.5 degrees and difficult even to realize the 2 degrees target in the year 2100. Yeah, and this is a graphic from the IPCC report from 2019, and the blue bars represent the mitigation potential. So which diet can reduce most greenhouse gases? And as you can see, the vegan diet is on top and has the best or the biggest mitigation potential for greenhouse gases.
All right, and so coming to the end of our presentation, we want to give you again an overview of the role of agriculture and its impact on planetary boundaries. And taking data from different studies, we can estimate the impact on planetary boundaries. You see the black dots, and they represent the share of agriculture. And again, we can be very certain that most of the share comes down to animal agriculture. You have to note as well that it's an older graphic, so for example, freshwater change and novel entities wasn't quantified like it is today, because it's still ongoing science.
Yeah, and to emphasize the share of animal products in agriculture, here we have different graphs. The red bars are animal products, the footprint of animal products, and the green bars are plant-based products, food products. And on the left top, there's freshwater withdrawals. On the right, we have eutrophying emissions. On the left down there, we have land use per kilogram of food, and there's greenhouse gas emissions. And as you can see, animal products are always tend to be on the top and have the longest columns. What's not so sexy is that coffee is also not so sexy for environment. I'm sorry. Chocolate too. Yeah.
So again, coming back to the 10% law, if there's one thing you take away from this presentation, make it this biophysical law that we can never bypass. So all of this nonsense you hear about, for example, feeding algae to cows to reduce their methane emissions, it's not gonna be the solution. So you can, with this, it's a very powerful tool because you can debunk a lot of the myths that are being propped up by animal agriculture lobbyists. Just think about it, if you have an element that's so wasteful, something like regenerative grazing, how can this be regenerative when it's just so wasteful? Yeah.
I think we're running out of time, so we're going to skip the rest. Wait. 2 more slides. That's why we need the plant-based treaty. Leah presented it before, and I think you all should endorse it right now if you haven't yet. Thank you.